I am Aniket Koul, and today we'll be discussing the 19th problem on the CP-31 sheet by TLE Eliminators under the 1200 questions. So I'll be moving to the CP-31 sheet, and we can see that the 1200 parameter has been checked. So I'll be scrolling down to find my 19th problem, make them equal. So let's begin. Now the problem statement is as follows. Theophanes has a string S1 till Sn and a character C. He wants to make all characters of the string equal to C using the minimum number of operations. In one operation, he can choose a number x where x lies between 1 and n, and for every position I where I is not divisible by x, replace S of I with C. Find the minimum number of operations required to make all the characters equal to C and the x's that he should use in his operations. Now the input format and constraints are as follows. The first line of the test file would contain a single integer t denoting the number of test cases, and this can go up to 10 power 4. Then the first line of every test case would contain a single integer n denoting the size of a string, which can go from 3 to 300 power 5, and also lowercase Latin letter c denoting the character c in the problem statement. Now the second line of each test case would contain n lowercase letters denoting the string s, right? And now it is also guaranteed that the sum of n overall test cases does not exceed 300 power 5. Now for every test case, we have to output firstly on the first line a single integer m denoting the minimum number of operations to achieve our result, and then on the next line we would print nm space separated integers x1 till xm denoting the x's that should be used in the respective operations. It is also given that it can be proved that under given constraints an answer always exists. If there are multiple answers, we can print any one of them. Now, as we have read the problem statement, we can move on to understand it. Now, for every test case, we are given three things, that is n, c, and s. N is an integer which denotes size, right? And we'll discuss what size it denotes. C is a character, and for our question, we'll only be dealing with lowercase alphabetical characters. S is the string, and this string is of size n. Right. Now we are given that we have to make all characters or all letters in S equal to C. Right. This is what we want to achieve. Now, in every operation, what we can do is choose some value x, where x lies between 1 and n. And now, for all indices I in this string, so I goes from 1 to n, if I mod x is not equal to 0, then we can say that I can convert S of I to C. This is our single operation. So we choose some x, then for all I from 1 to n, those indices which are not divisible by x, we convert S of I to C. This is a single operation, and now we have to output two things. The first one would be the minimum number of operations, right? This would be the first line of our output, and the second line of our output would be the x values that we choose for those operations. So let's say if we have two operations, so x1 would be here, x2 would be here, and the first line would be 2. So first 2 and then x1 and x2, and this should be in the same order, right? Now let's take a sample case to understand the problem better. Let's take these two. So let's paste them here and remove anything we don't need. Also, let's increase the font size. Yes. this, and this is it. Great. So now these are two different test cases. For this test case, this is the N, this is C, and this is S. Similarly, here also this is N, C, and S. Right. Now for the first test case, we have N equals 4, C equals A, and S equals B, A. Now, what can we do here? Let's see. So if we mark the indices 1, 2, 3, 4, right? These are the indices. Now if I choose for some operation x equals to 2, let's say this is my x for the first operation, and now let's consider all those indices which are not divisible by 2. So that is 1 and 3, right? So s of 1 would become a, and s of 3 would also become a, right? So now my new string comes out to be a, because this has changed, this has become a, and this was already a, so there is no change, but still we'll apply the operation here. The new strings become this, and as all the characters are equal to a, we have satisfied our condition, so we'll require only one operation. So the answer here would be one operation, and we used x equals to 2. We should remember that there can be multiple answers for a given test case, and the question allows it. The only condition is that this value should be minimum. Now for the second test case, n equals 4, c equals b, and s equals b, z, y, x, right? So now let's again mark the indices 1, 2, 3, 4. Now what we can do is, for first operation we can choose x equals to 2. So that would mean s of 1 would become b, and s of 3 would become b. So my new string now comes out to be b, z, b, z. This is my new string because I have changed this one and I have changed this one to b. Now on this new string, I can apply another operation with x equals to 3. So if I write the indices here again, so these are 1, 2, 3, 4. Now s of 1 would change to b, s of 2 would change to b, s of 2, sorry, let's write it here. S of 2 changes to b, and s of 4 changes to b. This one, and this one. So finally, my new string comes out to be b, 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 and b. And as it has uh, reached our expectation, so we can say we required two operations to perform this, and first operation had x equals to 2, and second operation had x equals to 3. This would be my answer, right? So we can confirm that as well. So for the first one, we had one operation with x equals to 2, and for the second one we had two operations with x equal to 2 and 3, right? Now as we have considered all the sample test cases, we can move on to discuss the expected time complexity. Now it has been given that sum of n overall test cases does not exceed 3 into 10 power 5, right? Now that means we can write the time complexity, instead of writing it as t of some function of n, we can write it as O of f of n, because there is a bound or sum of n overall test cases, so we don't need to include t. Considering that fact, we can say another thing that let's say we have O of n, so that would run in 3 into 10 power 5 operations. O of n log to the base 2 of n would run around 3 into 10 power 5 into 20, because 3 into 10 power 5 is approximately, log of that value is approximately 20, and that is around 6 into 10 power 6, and O of n square is about 9 into 10 power 10. But we know for a fact that on Codeforces we can run about 10 power 8 elementary operations in 1 second. So that would imply that O of n runs perfectly fine. O of n log n also runs fine, but O of n square does not, because it exceeds the limit of 10 power 8. So again, we would be requiring a solution that runs in the vicinity of O of n or O of n log n. Now, as we have discussed the exponent time complexity, we can move on to discuss the solution. Now, let's make some assumptions and let's try to prove them. My first assumption would be that no matter the given string and no matter the length of that string and the character C, I can always satisfy the given conditions in less than or equal to 2 operations. This is my assumption. Now we'll try to prove this. Right. So what is our operation? We say that if we have a string, so let's denote the characters of the string by like this: s1, s2, s3, so on till sn. If I choose any x in a given operation, all those indices for which I mod x is not 0, I change them to C. Right. So if I could choose some x1 and x2 in these two operations such that their union of all the indices that they cover is itself the set of 1, 2, 3 till n, then they would cover the whole array, right? Imagine x1 covers few indices I1, I2, I3, I4, so on till I K1, right? And x2 covers the indices J1, J2, J3, J4, so on till JK2. So these are the set of indices covered by x1 and x2, right? If I take the union of these two sets and it comes out to be the set which is 1, 2, 3, so on till n, that would mean these two x values cover the whole string S, right? So if I can find a pair x1 comma x2 which satisfies these conditions, then I would be able to convert all the elements of my string S to C in only two operations. So now let's think of what x1 comma x2 could be to satisfy this. Let us say that if x1 is n minus 1 and x2 is n, let's say what it does. So if x1 is n minus 1, wouldn't it cover all the indices from 1 till n minus 2 and all the indices, not all the indices, there will be only one index left actually, and that would be n. Think of it for a moment. That if I choose x equals n minus 1, all these values from 1 to n minus 2 would be less than n minus 1, right? And if some value is less than x, so let's say I mod x, and I is less than x, wouldn't that mean that I mod x is not equal to 0? Self-explanatory, right? So that would satisfy this range, because in this range all the elements that is from 1 to n minus 2 are less than n minus 1. That's why their mod with n minus 1 would not be equal to 0. Hence all these indices remainder won't be 0, so they would be covered. Also n. Why? Because we know that x plus 1 mod x is always not equal to 0, apart from the fact when x is equal to 1. So if x is not equal to 1, then x plus 1 mod x would never be equal to 0. You can check that for yourself, and it is quite self-explanatory as well, right? So these would be the indices covered by x equals n minus 1. Now if I go to x equals to n, wouldn't it in the same manner cover all the indices from 1 till n minus 1, right? Because all these indices are less than n, and hence the remainder with n would not be 0. So all these indices would be covered with x equals to n. So now if we take the intersection of these two sets, we see the first set is 1 to n minus 2 union the index n, and the second set is 1 till n minus 1. So the intersection would indeed be the range 1 till n, right? The intersection of x1 equals n minus 1 and x2 equals n. So I have proved in a way that yes, if I have x1 equals n minus 1 and x2 equals n, then for any given n, any given s, and any given c, I can always satisfy all my conditions in only two operations. That is clear. And you can also check it with the constraints, because n is greater than equal to 3, so that x equals to 1 case will never occur. So we can always say all the assumptions are true for the given constraints. Right. Now we have proved that we can always satisfy our conditions in less than equal to two operations. Right. So now let's manually check that what would be the conditions for my answer to be satisfied in zero operations and my answer to be satisfied in one operation, right? Because if I don't need to do any operations, or if I need to do only one operation, then that would be my answer. Otherwise, two would always be my answer, right? So now let's check what would be the case when I would need no operations. That would be the case when all the characters, that is S1, S2, S3, so on till Sn, are all equal to C. So if all the characters of my string S are already equal to C, that would mean my answer or my condition is already satisfied. So I don't need to run any operations. And now let's check what would be the case when the answer occurs with only one operation. Let's check. So the case when the number of operations required is equal to 1 would be when I find some given x. Okay, I find some x for which all I where I mod x is equal to 0. Now pay attention here, because I'm saying where all the indices where I mod x is equal to 0, it satisfies the condition that s of I is equal to c. I need to find these conditions. I'll repeat again. I need to find some given x, some x for which all those indices where I mod x is 0, they also satisfy the condition that s of I is equal to c. Now you may ask, how does that help? Let's see. Aren't the indices covered by the condition I mod x equal to 0 also the indices which will not change when I apply the operation with this given x, right? So these all indices would be untouched. Only the indices where I mod x is not equal to 0 would be changed to c, right? So all those indices which are not being touched, if they are already equal to c, that would mean if I apply the operation with this given x, then the whole string changes to c, right? All the characters change to c. If I give an example, so let's take an example where I have a string of length 8, and let's say the string is uh, A, B, C, Z, D, E, A, Z, right? Now, if I choose x equals to 4, you can see all those indices where I mod 4 is equal to 0. Those indices are I equals to 4 and I equals to 8, right? These indices. and these indices are already equal to z. So if I choose my c equals to z, I can say that for all indices which satisfy the condition that I mod 4 is equal to 0, we also have the condition that s of I is equal to z, just c in our case. That's why if I apply an operation with x equals to 4, what would happen is it would change this one, this one, this one, this one, this one, and this one. So it would change these 6 indices. All of them would be changed to z, and hence my new string would be z, z, z. This was already z, and then all three become z, and this was already z. So now the whole string only consists of z, and hence it reaches my condition. So I can say yes, my answer was achieved in only one operation. So these are my given conditions. So now I have discussed the cases where my answer requires only 0 operations, where my answer requires 1 operation, and I have also proved that in all other cases my answer would be reached in only 2 operations. Right. So now let's discuss the time complexity. Now for the case where I have to check for 0 operations, I would just need to run an O of n loop and iterate through the whole array. If all the characters are equal to C, my answer is 0, otherwise it's not. So this case takes only O of n time, right? And this case is O of 1 time, right? Because if this does not satisfy, this does not satisfy, I can simply print out 2 and n minus 1 and n, right? So that would be my answer. So this takes O of 1 time. Now let's consider the time complexity of the case where I have to check if the answer exists in one operation or not. So what I'm doing here is trying to find some x for which I get these two conditions, right? So how do I find this x? Let's do a smart brute force, right? Not a very vague brute force, but bit optimize it. So what I'll do is repeat in a for loop that what I just said, right? So I will run a for loop that would the I would go from 2 till n, right? Both of them included. And now I would run another nested loop here, j. Now j starts from I and goes till n again, but it takes increments of I, right? So what I do is I write j is equal to I, j less than equal to n, but j plus equals to I. So what I'm doing is basically j will visit all multiples of I, right? Because j starts from I and then j will go to 2i, 3i, 4i, and so on. So j will visit all multiples of I less than equal to n. Now for all these multiples of I have to just check if s of j is equal to c or not. And if for any given j, if s of j is not equal to c, then I would just break from this loop and say that for this given I, which represents my x for this case, the answer is not possible. So now do I plus plus and check for another x, right? And if for some given x, all s of j satisfy the condition that they are equal to c, then I would say yes, for this given x, my answer exists, and hence my answer is 1. Also remember, just for a fact, that I would first check for the 0 condition, then for the 1 condition, then for the 2 condition, right? Now let's discuss the time complexity, right? If I have a given I, what I'm doing here is iterating through all the multiples of I, right? So if I want to check the multiples of a given number I from 1 to n, how many multiples do I have? N by I, right? I has n by I multiples from 1 to n. So 1 has n multiples, 2 has n by 2 multiples, 3 has n by 3 multiples, 4 has n by 4 multiples, so on till n has only 1 multiple. So the number of iterations cumulative that I would take is n plus n by 2 plus n by 3, so on till n by n, right? Because 1 is n by n. And if I take out the numerator common, this is 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, so on. And this is on the order of n log n, right? This is natural log, but again you can convert natural log to log base 2 by multiplying with some constant factor, right? And when we are talking about the asymptotic time complexity, we can always ignore these constant factors. So I can say that for the case where I'm checking the condition that can I satisfy my conditions in only one operation, it would take order of n log n time complexity, right? So the 0 case was taking O of n and the 2 case was taking O of 1. So overall, I can say in the worst case, I would go and log n complexity. And as there is a bound over sum of n overall test cases, so I can say that the overall complexity overall test cases is also O of n log n. Now let's move on to the implementation part. The implementation part is also quite simple, as same as we discussed in our explanation. So now first of all, I take the input for the number of test cases. Then for each test case, I take in the input for n, the size of the string, and c, the character here. And then I take in the input for the string itself. Now this is the case where I am checking for 0 operations. So check 0 is basically telling me initially it is true. So after this for loop, if it remains true, that means all the characters of my string are equal, and hence I can perform 0 operations and satisfy all my conditions. That's what I'm checking. All the characters should be equal to C. If in any case it is not equal to C, check 0 is equal to false and I break. So this condition would take O of n time. Right. And now, like I said, if check 0 is true, then I simply output 0 and move on to the next test case. Now, this is the condition, this is the code where I check for one operations, if my answer is possible in one operations. So val1 basically tells me the value for which if I make x equals to val1, then I would reach my conditions in only one operation. So initially val1 is -1. So if I at the end of the operations as well, val1 remains -1, then I can say that uh, in one operations we cannot satisfy our conditions. So now, as I said, the outer loop runs from 2 to n. The inner loop runs from I to n with increments of I, and is possible is a boolean variable which is initially true. Now, if for all multiples of I have I have written s of j minus 1 because these are indices in one based indexing. But my string stored in my memory is zero based index, right? So that's why I have to change j to j minus 1. Now, if all the multiples of I are equal to c, then there is no issue. But if for any one multiple its value is not equal to c, then I change is possible equals to false and break, right? Now, at the end of this inner for loop, if for any I is possible remains true, that means if I do x equals to I, then I can have my conditions satisfied in one operation. So that's why I do val1 equals I and I break. Because once I have found my val1, then I don't need to go further, so I just break. And as discussed, this takes O of n log n time. Now, if val1 is not equals to -1, as I discussed, this means that yes, I have found some x for which one operation satisfies all my conditions. Then I output 1 and the value val1, and I move on to the next case, right? And if none of these satisfy, then that means if for 0 operations also I can't find a solution, and for one operations also I can't find my solution, then I have to find a solution that will always exist for two operations, right? So that is n minus 1 and n. So I output that if none of the other conditions satisfied. And coming to the total, uh, let's discuss the total time complexity. So as discussed earlier, this would be n log n, and the total space complexity would be O of n. because I'm using only linear space to store the string. So I hope you like the problem. For the ending remarks, I would like to say that this problem utilized a very clever observation to prove that answer always exists in less than equal to operations, and then even for checking that answer exists for one operation or not, it utilized a very clever way of brute forcing over all multiples of a given number and proving that this brute force will run under the constraint of n log n. Thank you.